Here we are at video number 2, so it is lesson 3-17B, and we're going to start out this lesson with this video with the graph of Anna's height on her birthday. And I've got my glue stick here. I've actually found some glue stick at my house, and we're going to glue this bad boy down. And again, mine is in color because, well, that's the printer I have at home. And unfortunately, yours will be in black and white because, well, the school doesn't have a colored printer that can print on such a large level. Now, again, one of the things we're going to do every time is when we start looking at graphs and charts and things like that is we're going to start looking at, well, does it have a title? Here's the title, Anna's height on her birthday. This is our scale, height in meters. This is the increments in terms it goes up every year, and it's labeled Anna's age. Now, when we think about what we learned with lesson 3-16, is this discrete or is this continuous data? Well, if we think about it, continuous data involves time. Okay, continuous data is over measurement over time. So this is continuous data. All right, now we've got this graph, and let's think about some questions. First question is, how much growth, and you don't have to write this, growth between her third and fourth birthdays. And I'm just going to write B days. Okay, how much growth was between her third and fourth birthday? Okay, we're going to look at her fourth birthday because we're going to take the bigger number, generally minus the smaller. So we've got 1.10, and then her third birthday was about 1.08. Now remember, we're going to subtract because we're going to take the larger from the smaller from the larger, and we line up our decimals. 0 minus 8 we can't do. We got to borrow some sugar. 1 becomes 0. This becomes 10. 10 less 8 is 2. 0 less 0. Bring down my decimal point. That's 0. So between her third and fourth birthday, Anna grew about 2/100 of a meter because this is in meters. All right. Our next question: what was Anna's height on her 6th birthday? What was her height on her 6th birthday? Well, let's find 6, age 6, climb up to the top right here, scoot over there, and it looks like it's in between 1.14 and 1.15, so it's 1.15 meters. And our final question for this graph is, between what ages did Anna, oops, I should capitalize Anna, shouldn't have capitalized that D, have a growth spurt? So looking at that graph, a growth spurt would be considered the largest jump between the two numbers. So where did Anna have her growth spurt? Well, here and here it just goes up 2. Here it goes up 1, 2, 3, 4. Here it only goes up 1. So between the ages of 4 and 5. Okay, and that's where Anna had her growth spurt. Now, ladies and gentlemen, that's nothing really different than what we've done before, as I shift this up so you guys can see it better, because we're going to add another graph to this. And this is the graph, the length of common beetles, not to be confused with the beetles that sing. These are beetles that just probably crawl around and get stuck in your hair and things like that. Now the question is, after I said that, how many of you started scratching your head because all of a sudden you're feeling that creepy crawlies on your body? That's funny. All right, and I'm going to put this one on this side just because, well, I can, and you can't stop me. All right, I probably didn't put that it very straight, so I'm the guy with the crooked graph in his notebook now. All right, let's look at our parts of this chart. We have our title, length of common beetles. We have our measurement, and then we have this, and we have our length in centimeters. And notice it goes up by 0.2, 0.2, so 0.2, 0.4, 0.6, 0.8, 1. 1.2, 1.4. And then here we have different kind of beetles. We have the bark beetle, the firefly, the ladybug, the seed beetle, and the tumblebug, which I think they just made up. All right, so let's look at, we've got 3 questions here. The first one is, what's the length of the bark beetle? Okay, so we're going to find bark beetle, and then we're going to go up, and it's in between the 0.2 and 0.4, so it's going to be 0.3, and that's centimeters. All right, our next one is, how many bark beetles, and this is going to take me a while to write, bark beetles, again, you don't have to write these, would you have to line up end to end to be the same length as the tumblebug? All right, so what we need here to do this, we need the length of the bark beetle, which we know is 0.3. Tumblebug is here. So what we're going to do is we're just going to skip count, and what I'm going to do is I'm just going to make little marks on my graph. So this is 1, go 1, 2, 1, 2, so 0.3, so 1, 2, 3 lines, 1, 2, 3 lines, 1, 2, 3 lines. So it's approximately, and this is the approximate sign. Okay, straight lines would be equal, but approximately 3 bark beetles. All right. Our final question is, if we come across a bug and its actual length, whoops, I need a T, is 0.150 centimeters, what beetle did we find? Okay, so now we're going to look for 0.15. We got 0.2, that's too big. 0.1 is going to be somewhere in here, and somewhere across here should be, that would be the seed beetle. All right, so that's working with our decimal. We're working with graphs only with decimals. And what you see, it's not all that different than working with graphs with whole numbers. Right now, the biggest difference is our numbers are much smaller. So that's video number 2. Stay tuned for video number 3, in which basically video number 3 is going to be your practice, and we're going to see how we do. And the weird thing about it is I'm going to just give you the instructions, and then you're going to have to go to work, and then I won't be able to pause anything. So we'll see how that goes.